Greetings of the day, dear students. In this video, we are going to discuss about the concept of feedback amplifier. We will see in detail what do you mean by positive feedback, what do you mean by negative feedback, and what is the principle of feedback amplifier, what is the circuit diagram we are having, right? And also, dear students, the circuit diagrams we will discuss, and the gain without the feedback, the variable A, output voltage by input voltage, and what could be the new value of gain, some A dash with the help of feedback. That is, without feedback the gain is A, and with feedback the gain is represented with letter A dash. So how the variable value A dash will be if it is positive feedback and if it is negative feedback, and what could be the magnitudes of input and output voltage if it is positive feedback and negative feedback. All those things we are going to discuss in this video. Clear? Right. Dear students, if you come across the word feedback, it is like some part of the output is taken out and will be given to the input. Simply to say, some part of the output is taken as and will be given to the input, right? And it is going to control the output. Further, it is going to control the output. So here the circuit will be consisting of, the feedback amplifier circuit will be consisting of an amplifier and also a feedback circuit, right? Now when we call it as positive feedback, if you have applied some part of output is taken out and applied to the input so as to increase the input voltage, then it is to be called as positive feedback. I repeat again, you are taking out some part of the output, some fraction of output is taken out and given to the input, and your intention is to increase the input voltage, then it will come under positive feedback. Now there are other names for that. It is the regenerative or direct feedback. It is called as regenerative or direct feedback. Now this positive feedback is going to produce some excessive distortion will be produced, right? Because of that, it will be rarely used in the amplifiers. It will be rarely used in the amplifiers because however, because of it increases the power of the original signal, it will be used in the oscillator circuits. Instead of amplifier circuits, it will be better, it will be used in more in the oscillator circuits because of the excessive distortion, right? It is going to give. Now the negative feedback, how do you understand the negative feedback? Negative feedback means some part of the output will be taken out and will be given to the input so as to reduce the input. If you are applying some part of the output to the input such that the overall input will get reduced, then it is called the negative feedback. Now the negative feedback, other names we are having, that is the degenerative feedback or inverse feedback. Dear students, the other names are degenerative feedback or inverse feedback, right? Now negative feedback is frequently used in the amplifier circuits. Negative feedback is frequently used in the amplifier circuits. Now let me see. For example, this diagram A represents the circuit without any feedback. Already we have discussed in our previous basics that output voltage by input voltage will give you the gain. Capital A indicates the gain. A is the variable used to indicate the gain. So output voltage by input voltage without any feedback is simply represented with letter capital A, gain. Now in this diagram you can observe some part of output, that is some beta times the output is taken out and is given to the input. Now this new output, some V0 dash, beta V0 dash is the new output, right? So beta times V0 dash is now given to the input. So this is the feedback loop. This is to be called as feedback loop. Now depending upon whether it is positive feedback or negative feedback, what happens is the input voltage now becomes V input plus or minus beta times V naught dash. Very, very important. Beta times V naught dash, where beta is the some small fraction. V naught dash is the output voltage. Vi is the existing input voltage. Now, here we can observe that when amplified A times, now this is acting as an input. Vi plus or minus beta V naught dash is acting as an input. Now after passing through this amplifier, this input will get amplified A times. So here now it becomes A times Vi plus beta V naught dash. Therefore our output will be A times Vi plus or minus beta V naught dash will be our new output V naught dash. Very, very important. In another way, if you write it, okay, if you take out V naught dash common, V naught dash times 1 minus beta A, 1 minus beta A is equals to the A times Vi. A is the gain without feedback, right? Yeah. Now let me find out the new gain, new amplifier gain. Let it be A dash with feedback. A is without feedback. A dash is the gain with feedback. A dash is the gain with the feedback. Right? Now A dash will be new output V naught dash by Vi. Just now we have seen from the above equation V naught dash, if you write this one, if you further simplify this one, V naught dash by Vi, we will get A by 1 minus beta A. A by 1 minus beta A. This is our A by 1 minus beta A. Right? So A dash will be equals to A by 1 minus beta A if it is positive feedback. Now if the feedback is negative, what happens is 1 minus bracket of minus beta A. So it is 1 plus beta A. Very, very important. Dear students, you can clearly observe if it is positive feedback, you will get minus here. If it is negative feedback, we are getting the positive here. Right? Now this beta A, the term together beta A is called the feedback factor. It is called the feedback factor. It is called as feedback factor, right? And beta is the feedback ratio. Beta is feedback ratio. Now 1 plus or minus beta A, 1 plus or minus beta A is called the loop gain. Very, very important. This term is called loop gain. Beta A is called feedback factor. Beta is called the feedback ratio. 1 plus or minus beta A is called the loop gain. Right? Now, if it is negative feedback, as we have discussed earlier, A dash will be equal to A divided by, right, 1 plus beta A. 1 plus beta A. So here, for example, if you assume A equals to some 90 and beta equals to some 0.10. Now what could be the new gain? The gain without feedback is 90. Now the gain with feedback will be A dash equal to A by 1 plus beta A. 90 by 1 plus 0.1 into 90. It is now 9. Right? So what do you observe? The output has reduced. The output has reduced. The gain is reduced. That is the reason why it is called degenerative feedback. A lot of voltage gain is sacrificed due to the negative feedback. This is also called degenerative feedback. Negative feedback is also called degenerative feedback. Right? Now, dear students, if you observe, if beta A is very much greater than 1, right, obviously A dash will be equals to A by beta A, that will be almost equals to 1 by beta. It means that A dash, the new gain with feedback, is depending on beta. Beta is the which variable? Beta is called feedback ratio. It is depending upon feedback ratio, right? Yeah. Now, but it is very stable because it is not affected by the changes in temperature or device parameters or supply voltage and any form of aging of the circuit components, etc. All those parameters are not going to affect the value of beta, right? Because the resistor can be selected very precisely with almost zero temperature coefficient, right? Because of this, we are able to achieve highly precisely stable gain with negative feedback. If highly precisely stable gain can be attained with the help of negative feedback. Okay, yeah. Now let me discuss about the positive feedback. For example, in this variable A dash equals to A divided by, here we will get in positive feedback minus sign, right? Now 1 minus beta A will be less than 1. So here A dash will be very much greater than A, right? For example, you can observe here, if A value is 90, beta value is some 0.01, what happens here? 90 by 1 minus 0.01 into 90. So A dash we got around 900. So without feedback the gain is 90, but now with feedback the gain is 900. It has been multiplied a lot. So that is the reason the positive feedback is also called as regenerative feedback. Now if you observe the beta A value, if under any circumstances beta A, if it is made equal to 1, then A dash is equals to A divided by 1 minus 1, that is something by 0. It leads to infinite. So of course practically it is not possible, right? Electrically speaking this cannot happen. But what happens is it becomes an oscillator instead of amplifier. It now acts like a oscillator, right, which supplies its own input. In fact, the two important and necessary conditions for the circuit oscillation are, what are those? The feedback must be positive and beta A value must be equals to the 1, right? So this is the necessary condition for the circuit to act like a oscillator, right? Yeah. So this is about the positive feedback. In this entire discussion, the important point is, if it is positive feedback, the value has been multiplied a lot. A dash is given by A divided by, these two formulas are very important. A dash for positive feedback is A by 1 minus beta A. For negative feedback, A by 1 plus beta A. Right? Now A indicates the gain without feedback, A dash indicates the gain with feedback, right? So gain, anywhere if you come across the word gain, output by input, this is how it works. In positive feedback, some part of the output is taken out and applied to the input so as to increase the input voltage. In negative feedback, some part of the output is taken out and applied to the input so as to decrease the input, right? So this is what all about the concept of feedback amplifier. Right? Okay, thank you.